So here we have the 2016, this is question 2A, this is leaving cert ordinary level, and this is a question on trigonometry. So we're asked to find the area of the triangle. So we have two ways that we can find the area of the triangle. The one that we're most used to is, say, to get the area is half the base multiplied by the perpendicular, so that means perpendicular height. So if we were to do that on this triangle, if we were to take 12 as our base, we would have to also get the perpendicular height here. So we would have to get this height here. So we'd have to use that formula. But there is another way we can get the area of a triangle. Say if we have a triangle ABC, the area is a half of, say, AB, so two sides, so a half, two sides, and then sin C, so the angle in between. So what we can do to get the area of this is a half, so by two sides and the angle in between. So the area, a half, two sides, which are these, and the angle in between. So the area will be a half. So we could call this A, we could call this B, and this could be angle C. So say this would be then side C. So it would be a half, A, which is 12, B, which is 8, and then sin of the angle in between. So so it has to be the two sides and then the angle in between. So that'll be a half multiplied by 12 by 8, and then sin 30. So then I get my area is equal to 24. So we could write 24 units squared. So that's my area of the triangle. And then in part B, I have a triangle of sides of length. So my sides are 3 centimeters, 5 centimeters, and 7 centimeters, and I'm asked to find the size of the largest angle in the triangle. So firstly, the largest angle in a triangle is always going to be opposite the largest side. Largest angle will be opposite the largest side. So if I'm to say, what I would do first is maybe draw kind of a rough sketch of this triangle. So say if we had side of 7, or say if this was 5 centimeters, and then we have a side of length 7, and so say it's not going to be a right angle triangle necessarily, so this is say not a right angle. So say this was 7 centimeters and say this was 3 centimeters. So it's not necessarily going to be right angle. So that's not necessarily a right angle. So find the size of the largest angle in the triangle. So the largest angle is going to be opposite the longest side. So it's going to be this angle here. So when I have a triangle that's not right angled, the rules that I have, the tools that I have available are, and I'll just get, so if I have, so we can just write them out. So if we have a right angled triangle, so if we have a right angled triangle, we can use Pythagoras, and we can use our trigonometric ratios, which are sin, cos, and tan. We don't know this is a right angle triangle, so we can't use them. If in all triangles, we can use the sine rule, or we can use the cosine rule. So if you want to figure out which do we use, sine rule or cosine rule, what I would say is, do I know at least one side and its opposite angle? If the answer is yes, I use the sine rule. If the answer is no, I use the cosine rule. So in this case, I don't know any angles, so I don't know at least one side and its opposite angle. So I'm going to have to use the cosine rule. So I'm just going to draw my triangle again here. So this is 7, 3, 5, and this is my angle that I want. So say if I'm to use the cosine rule, so the cosine rule is in our log tables. So it's on page 16. So it says that if we have a triangle A, B, C, that the cosine rule, say if we want to get angle A, well, we have to put the side A opposite of that angle in front. B squared plus C squared minus 2BC cos of A. So the angle we want is this one. So we could call this angle A, but then the side opposite that will be side A. And then we could call this angle B. The side opposite that will be side B. We can call this angle C. The side opposite that will be side C. So if we were to plug this into our formula, so our angle is, so the angle is what we want to figure out. So we can we can rearrange this to get our angle in front, or we can just plug everything in and then rearrange it after. So the side that goes in front is going to be the side opposite the angle that we're dealing with. So it's going to be 7 squared. So that's going to be my A squared, and my B squared is just going to be one of the other sides. So 3 squared, and my C squared is going to be 5 squared, and then that's minus 2B, which is 3, C, which is 5, and then cos of A, and A is what I don't know yet. So now I'm going to actually bring this down here. So I'm going to work this out. So 7 squared is 49, 3 squared is 9. That's going to be 9 plus 25, so that gives me 34. And then 2 by 3 by 5, so that gives me minus 30 cos A. So now I have to kind of rearrange it to get cos A by itself. So what I might do firstly is subtract 34 from both sides. So then that'll be 49 take 34 is equal to minus 30 cos A. So that's 49 take 34, so that's 15 is equal to minus 30 cos A. And now I have to get cos A just by itself. So I'm dividing both sides by what's attached to the cos A, so by minus 30. So 15 divided by 30 gives me a half, so it'll be minus a half is equal to cos of A. And now I have to get the angle, so I can do cos, so the angle A is going to be cos inverse, and then minus a half, so cos inverse minus half. So I get that my angle is 120 degrees. So that is going to be my largest angle because it's going to be opposite my longest side.